This is quiz 4. I've already written up most of the stuff about the problems to save a little bit of time. So problem 1 has us find the limit of that expression, and if you do a reality check, oops, missing the arrow there, as x approaches 4. So if you do a reality check here, what's going on as x approaches 4? The numerator, you get 16 minus 16, which of course is 0. The denominator, you get 16 minus 12 minus 4, and 16 minus 12 is 4, minus 4 is 0, so you have a 0 over 0 bad news situation. So what we have to do is some algebra, some kind of a trick, as x approaches 4. Well, looks like there's a lot of factoring that we could do. The numerator is x times x minus 4. The denominator, if we have any luck at all, would factor this way. You're going to have x on both sides, and it's going to be a plus and a minus, because that's the only way you're going to get a negative 4 out of this. And we need a couple of numbers that multiply to give you 4 and add to give you 3, so looks like it's got to be negative, so it looks to me like you're going to have to put 4 here and 1 there. Let's just try that. X squared minus 4 plus 3 is minus 3. Minus 4 plus 1 is minus 3, and then minus 4. Okay, so after it's factored, yes indeed, x minus 4 will cancel, leaving us with the limit as x goes to 4 of x over x plus 1, and that's an easy limit because as x gets close to 4, we get 4 over 5. Okay. Again, here as t goes to 0, we have this term blowing up. This is number 2. The first term blows up, and the second term blows up. So we have an infinity minus infinity, and that's bad news because you can't tell what's happening. It depends on who's going to infinity faster. So we're going to have to get a common denominator here. And let's see, as t goes to 0. Well, there's a t that factors out of this. I mean, t squared plus t is t times t plus 1. So I really don't need to multiply 1 over t by a whole lot. I just multiply 1 over t by t plus 1 over t plus 1. So I get t plus 1 divided by t times t plus 1. And that gives me the 1 over t there. Minus, and then this has already got the common denominator, 1 over t times t plus 1. So that's what I'm dealing with. If you subtract across the numerators, this is going to give us, the 1's are going to cancel, and you're left with t over the common denominator, t plus 1. And that obviously allows us to cancel the t's, and as t goes to 0, we have a 1 down here. There's a 1 up there, so the limit is 1. Okay, now this problem involves absolute value. So you can't just erase absolute value. You have to think about what's going on in cases. So you need to know when is this quantity in the absolute value positive, when is it negative. And as luck would have it, this is a limit as x gets close to 2 from the positive side. So when x is getting close to 2 from the positive, that means that x has to be bigger than 2. Think of a picture. Here's 2. And x is getting closer to 2 from the positive side. So all of those x's have to be bigger than 2. So if x is bigger than 2, what can you say about x minus 2? Well, if x is bigger than 2, x minus 2 is positive. So you're taking the absolute value of x minus 2. But what does that mean if x minus 2 is positive? Absolute value doesn't do anything to positive numbers. So in this case, this limit is the same as the limit as x approaches 2 from the positive of x squared plus x minus 6 divided by x minus 2 without any absolute value, because the absolute value of x minus 2 in this case equals x minus 2. Okay, now we need to factor that expression. I'm running out of room. This is the limit as x approaches 2 from the positive, and this is going to be x minus 2 times something, I bet, x plus 3. Check that. X squared plus 3x minus 2x. Yep, that works. Divided by x minus 2. The x minus 2's will cancel, and you're left with x approaching 2 with x plus 3, so the answer is going to be 5. Okay. What happens when x approaches 2 from the negative? Well, then x is less than 2 in this case. So what can you say about x minus 2 if x is less than 2? If x is less than 2 and you subtract x minus 2, then the result is going to be negative. So what does absolute value do to something that's negative? Well, yes, it makes it positive, but how does it make it positive? It takes the thing that you give it and sticks a minus in front of it to make it positive. Now look carefully. X minus 2 is a negative quantity. So when you take the absolute value of it, you have to end up with a positive. So since x minus 2 is negative, the opposite of it is positive. So that's what absolute value does to it. It negates x minus 2 to make it positive. So this becomes the limit as x approaches 2 from the negative side of, let's factor out the numerator again, x minus 2, x plus 3. But now the bottom part, you can't just erase the absolute value. The absolute value of x minus 2 is now the opposite of x minus 2. And so the x minus 2 will cancel again, but this time you're going to be left with x plus 3 with a minus. So as x approaches 2, you're going to get 5 again, but at a minus. So it's minus 5. That's what the limit is. Okay, now before you took the limit, it might be useful to see what happened. If x is bigger than 2, like in this case, then you're getting x plus 3 as this function. So this function g of x is really a function that's written in two cases. It's either x plus 3 if x is bigger than 2, because that's in our first case. For any number bigger than 2, the absolute value is just going to leave x minus 2 alone, so absolute x minus 2 is x minus 2. So that cancels everything, and you're left with x plus 3. And then it's the opposite of x plus 3, minus x plus 3, if x is less than 2. And we can't plug 2 in, so 2 is out of the domain of this function g. So now I think we're ready to graph this thing. This expression is a line of slope 1, but it's a line of slope 1, y-intercept 3, but only when x is bigger than 2. So we have to be out here, bigger than 2, and we have a line of slope 1. We have to imagine it because we can't draw it on this part. But once you get to 2, you have a hole in it right here, and then it goes on from there with slope 1. That's this part of it. And then this part, if x is less than 2, we're on this side, and then we're getting this thing, which is a line. Let's spread out that minus x minus 3. So this is a line of slope negative 1, so it's going diagonally down that way. The y-intercept is minus 3, minus 1, minus 2, minus 3. But it's going to come in to 2. So it's going down, and it goes all the way through this point. And then it comes to this point where 2 is, and you're going to have a hole in it there too. And then it just goes up like that. Okay? And that's it for quiz 4.